is our motor controller section. You see these big, huge capacitors? And this heat sink here is probably on some triacs, which are electronic relays. They're what switches the compressor on and off. Okay, so we have our motor control unit built into the board. You could see a separate motor control unit would look just like this, but a little board over here, and I'll show you guys pictures next week and comparing the two pieces. Now the other thing is you have this main input here, but this here is probably going to be could be your Wi-Fi module. I don't know what this one is, I have to look. But this is, see, the power comes in here. And so the power is coming here to the main board. So this is our input power here. Look, our power cord into our main board. We have a fuse on the board. It's not a replaceable fuse, but it's a fuse on the board for safety. So this segment on here, these pieces here, what machine has something like this on it? Microwave. And what is that piece that has those pieces on it? It's a noise filter. So basically this is the input power right here, this segment, but this is the same thing as a microwave noise filter or washing machine noise filter. Whenever you have a motor that's a variable speed motor, on a lot of these washing machines we have them, or a frequency drive motor, so to speak, it works off of frequency, that frequency can feed back to the electrical cord into the home, and it can mess up radio or TV or something like that through the 120 volts going to the appliance. You'll see lines on TV. I don't know, you guys remember back in the day when someone was vacuuming and the TV's got lines or static on it, it's because the motor, that was a brushed motor, put a frequency back on the household electric and the TV was picking it up. On these newer machines, they do have a feedback that can go back into the home electrical. So this whole point here is the power supply coming in. Now you're like, okay, but what does that do for me? Well, it's easy to tell input power. Like if nothing worked on the refrigerator, this is where I go to check power coming into my board, right? Look at this plug here with 3 wires. What do you think this plug goes to?
The compressor.
How do you know it's a compressor?
Because I see the purple wire. And,
you see purple wire, but how does that tell me it's a compressor?
I just know.
You see purple wire down here?
No, from the relay, I think that's where it comes from, right?
If we look at this plug here, I don't know if the camera can see that. If we look at this plug here, we got black, purple, and dark blue, right? So if we look here, black, purple, and dark blue. There is no relay on this. You mentioned relay. This is an inverted compressor, so we have no relay and overload. This is a variable speed. The compressor can run faster or slower. If the compressor has a relay on it, it's not variable speed. It's just on at full speed or off. Okay? So if I wanted to ohm out my compressor, I could do it here, or I could do it from here. Okay? So on some of these, when they have a separate inverter board, you'll see not only 120 volts going to the inverter board, which if you look, what colors is my power coming in?
Red and black.
Red and black, my 120 volts, right? But look, I have a red and black over here. That red and black is my input power to my inverter board.
There's
Okay?
no voltage, right?
No, the inverter board is higher voltage. It's variable. You can check 120 in, but I couldn't tell you, oh, this is 200 volts or this is 20 volts. Because when a motor is running, it's at different speeds. When you first plug in a fridge and it's warm, how's the compressor going to run? Slow or fast?
Slow.
Why do you think slow?
Because you gotta kick. I think you gotta kick in.
Okay, but if it's a fridge, if you brand new fridge, you plug it in, it's hot, right? So if you walked into a house that's hot, you're going to put it on a slow speed, or you want it full speed?
Full speed, but
full
speed. It goes slow when it starts, right?
No, they go full speed when they're warm, and then as they get closer to the temperature, then they slow down to use less electricity. So then these little boxes here, they're nothing more than relays. A relay is just a switch. The control board sends a small voltage to a little magnetic coil, and it closes it or opens a switch. So one relay would be like fan motor,
Right.
One relay is going to be defrost heater. Another relay is going to be ice maker. Another one's going to be
Isn't that small?
compressor. Well, no, the compressor's one up here. I'm sorry. Condenser fan motor.
Evaporator fan motor.
Light bulbs. Everything that the board would control. Each one of these relays would be a different part for that. Well, you'd have to go to schematic to find out particulars. Then this here is our main processor. It's just like a computer. This is the brain. Okay. Now, on top of here, there's supposed to be a chip somewhere. Probably a chip like these here. These are like ROM chips. ROM means read-only memory, and that is when the factory programs how the board is going to react. When it sees this resistance thermistor, it knows the temperature. So these are processing chips here. These are the ones that are doing, you know, thinking. Okay. So you need to be able to look at this and say, oh, that's my compressor. Right. This is my input power. This is my main board. This one I'm not sure without looking at a schematic. On my unit, the hub, one of the boards over here is Wi-Fi. I can connect to my refrigerator through Wi-Fi or Bluetooth. Okay, so they could have a separate Wi-Fi or Bluetooth board here. And mine has 2 or 3 boards here and 1 or 2 boards there. The motor controller is not on the main board. It's separate. Right. On some refrigerators like the Electrolux, you see the compressor has that little gray box on the side of the compressor. That's the same as this one right here. It's the same thing. So there's a low voltage communication from this board to here telling the compressor how far to run. This is the power coming in. These components are what converting that voltage to these 3 terminals here.
The gray inverters that's on the compressors, that's on those variable speed compressors. It's
the same thing. Right. It's the same thing as here, but instead of putting this down here on the compressor, they built it all into one board.
Got it.
It's a little bit easier to troubleshoot when it's all on one board because if anything electrical on the board fails, you just change the whole board. Right. But when they start putting a board here, a board here, a board here, a board here, you're looking at all these boards and you're saying, okay, what does this board do? What does that board do? Right. You have to know that if I have a problem, my compressor's not running, everything else is running. That's all this part of the board does. I got voltage here, but my compressor's not running. So what I do, I ohm out my compressor. Compressor ohms good. I got voltage here. All my fans and everything else are running. I got to change this whole board. It could be a bad inverter. But in this case, it's not separate from the main board. Where the main board normally doesn't have a motor controller on there. So we're going to, next week we're going to pull out a bunch of these different refrigerators and we're going to look at the control boards. But maybe what we'll do is we'll leave this one open, not leave it open, but we'll open this one and open up a GE next to it and open up a Frigidaire or a Whirlpool next to it and look at each board and try to say the similarities between each board and the differences between each board. When you look at them, you got to know what the boards do. You know, we're working on the microwave in the other room and it's got different boards. One board's for the oven, one board's for the microwave. What part of the board controls the magnetron? What part of the board controls the fan motor? When you're troubleshooting, you need to know where on the board power's coming in, where power's coming out. Now, if you look at these plugs here with these small wires, what do these wires do? They're low voltage. They go to our LED lighting, they go to our sensors, our thermistors, they go to all our low voltage components. Some of our fan motors may be up here and not on our bigger wires. Why? Why would our fan motors be connected to something like this?
Because they're PWM.
Which is low voltage DC volts. You know, they may only be a 12 volt fan, but DC.
Or less.
Yeah. Okay.
Them little plastic fan.
Well, thermistors are usually like 5 volts, and then fan motors are usually like 12, but they're variable speed fans, just like the compressor. Now, these bigger wires are going to be for my water valves, my ice maker, my defrost heater. All of them are going to be on my bigger wires because they got to handle the amperage of the components. These little wires here can't handle the amperage of anything.
You'll toast the wires.
Okay, so We'll do like a little series. Like 2 or 3 times next week, we're going to open up a bunch of refrigerators. We're going to put them all side by side, one by one, and we're going to look and compare the boards.
Okay.
Any questions on these boards?
Shit.
No?
Not yet.
Okay, so right now we're just learning board identification. We're not learning to troubleshoot now
Right.
and read the schematic. That's in time, but let's learn all the different parts of them.
Got that on with that.
Mm-hmm.
I want to learn more about the compressor soon.
He's itching for it.
There you go.
You got the manual.
Yes, it's on my
I already stopped it.
Okay.
no.
All right, guys. I didn't want to make it too long because I know
Oh,
everybody's
beautiful.
in projects
Thank
and
you.
stuff.
Oh yeah.